Welcome everybody to my talk on Immutable Systems in the cloud. So, okay, just a glitch. So, is it better? that was funny. Okay, so, okay, just crack the ice. So let me tell you a story. This diagram represents the usual development and deployment workflow that all of us are used to use in our daily job. So we start with a team who develops stuff, either automation or code for your application, whatever. Then you run maybe Docker, whatever you want to run unit tests in your laptop, and then you share what you have done on a repository. Jenkins kicks in, run tests, and eventually you deploy stuff to pre-production environment or to live. Okay. Why are you telling you this? I've been working on automation projects, especially on OpenStack, Rackspace, AWS Cloud. Now I work at Microsoft, and I always use Linux and Python-based framework. What are we going to discuss today? We are going to discuss configuration management, because that is what I do, and it's really useful for all of us. Containers and microservices. I'm supposed to say containers, Docker at least once in my talk, so ticked. Orchestration is absolutely, we need to discuss that, and CI/CD, because obviously that's the right way to do things nowadays. Why I'm talking about these kind of things? So I'm pretty sure if you are here, you don't use the old-fashioned way of managing server. You are not supposed to SSH into any server. You don't care about servers. You don't treat them as snowflakes. They are just servers. Instead, what you are supposed to do is to write some sort of playbook which allows you to manage systems, to tell systems how they should manage themselves. And that is awesome, because you might use different technologies like Chef, Puppet, SaltStack, Ansible, whatever you want, to tell systems how to manage themselves. So you develop playbook, your automation on your laptop, you share things on Git repositories, and then when you are happy with that, you push those playbook, the runbooks, to a Chef, Puppet, SaltStack server. That's great. So essentially, what you are doing is you write once, and you reuse what you have developed in all environments, meaning on your laptop, on virtual, physical, bare metal servers, in different cloud that you might want to use. Okay, that's great. So what happens is that if you drill down a bit, you realize that it's not that easy. So you started managing virtual, physical, cloud servers, and you end up managing such a mess, that complexity, bunch of stuff, roles, groups, attributes, all kind of things that allow you to manage systems in the cloud. So essentially, you are dealing with a meta infrastructure. You are supposed to manage your infrastructure, and you end up managing two infrastructures. One which manages the other. So you are investing time, money, resources in doing something that you would be much happier not to do. If you want to use, say, Puppet, it might seem a little bit easier, but you need to take into account that if you want to compare apples with apples, you need to add, say, RTK, Hira, and additional components to manage your infrastructure as Chef allows you to do. So eventually, it's really swings and roundabouts. It's everything evens out. So it's the problem here is about managing complicated environments, and you don't want to manage complex environments. So the difference between the two is much about things when you know what the initial state is. From the initial state, you might be able to predict what the outcome is. The outcome is your project spec. You want to reach a goal. With a complex infrastructure, you know where you are, but you don't really know where you are going to. And that's the difference between managing complicated systems and complex systems. So essentially, you need to find a way to keep things simple, to version things, and to make things be repeatable. Okay. Back to the point. You are supposed to manage your infrastructure, to manage on-prem servers, cloud servers, virtual servers, with roles, with different groups of servers. And I'm pretty sure somebody might think that containers are the way to go. Unfortunately, when it comes to adopting containers or adopting the microservice pattern, the problem is that you might need to redesign big chunks of your infrastructure just to adopt those new tools. So it might be awesome for certain companies. So if you work at Google, Netflix, eBay, absolutely. You have tons of engineers who are able to deal with new things. But for most of companies I supported in the latest years, that wasn't really the case. So containers and microservices are awesome. Okay. For now, I might suggest you to consolidate what you are currently doing. As always, the truth lies in between. So you need to find a way to leverage what you already have in a better way, in a smarter way. So what could be a possible solution? Back to the point. This is the development and deployment workflow that we discussed at the very beginning. What if, at the end of this workflow, we create an image? So you already do what you are familiar with. You continue doing what you are currently doing, but at the very end, instead of running Chef, Puppet, Ansible against cloud servers at runtime, what if you just take an image of what you produced? So the idea behind this is you start with a vanilla image, you customize and install app, and that is where you reuse what you are already familiar with. So you might have playbook, cookbooks, manifest file, which allows you to provision stuff on your servers. Okay, that's great. You're already done, almost there. So just reuse what you have to customize and install your app on those servers. Then you run tests, and you take an MI image, which can be MI image in AWS, an image in OpenStack or Rackspace Cloud, or an image of a virtual server in Azure, whatever you want. It applies to pretty much all cloud servers. And then you reuse that image you store that image, you version it, you tag it, so that you're able to reuse that image in different environments. As always, if it's missing, it cannot break. So get rid of complexity. Get rid of configuration management at runtime in production, where every second counts. Let's discuss a very trivial issue. Say that you are managing your scaling group in AWS. So at runtime, iLoad hits your front-end web servers. You need to scale out, and you need to provision those servers at runtime. Every second counts. Let's say that the package that you are supposed to install is missing because you are leveraging, say, a PPA, and the package maintainer just removed that version because it's obsolete. Okay, so you are scaling up, and you have a new scaled server which is able to do nothing because it doesn't converge. It's not able to install a missing dependency. So, what's next? Okay, that is quite easy to fix. You might think, okay, we are in AWS, let's use S3, and I can just store that package in S3, and then I point my EC2 instance to fetch that package from S3. But that's another issue. You have just started managing packages on the maintainer's behalf in S3. So you just moved your problem from initial issue to another. So that's not really what you want to do. You want to develop stuff. You want to manage infrastructure, not to do someone else's job. How can you solve it? Phoenix servers. What is the definition of a Phoenix server? If it doesn't work, nuke it and reprovision it from scratch. That's the definition of a, of a Phoenix server. So a Phoenix server is a disposable server which allows you to nuke it if it doesn't work, or just leave it live if it works just fine. You need to bake the EC2 image, the AMI image. How can you do it? Just grab your Linux distro of choice, do stuff, so install application, run tests, whatever you want. At the very end, you just export it as AMI. Then you tag it, and you store it in a bucket. If you want to use that AMI image for your EC2 instances, you just need to, sorry, I'm struggling with this. You just need to pick it up from your S3 bucket. You just need to, you remember, you tagged that AMI image, so you just need to take care of picking it up with the right tag. And you can spin an EC2 instance up based off that AMI. And you're ready to go. So if you paid attention to what I just said, you might have spotted there is an issue here, because you are using the same AMI in different environments. But, sorry? Different environments require different configuration. So if you're using the same image in development, staging, pre-production, production, you might want to point it to different DSN databases or whatever. So you need to leverage some sort of discovery service. So spin it up in different environment and point to, and let it discover what is the right configuration for that environment. Or you can update that image at runtime with two different strategies. One programmatically with, as always, Ansible, Chef, Puppet, again, but you are using now configuration management system as a smart way, not just with brute force, running those over and over again every 30 minutes against servers. Or you can just, in time, reconfigure those instances with console or whatever technologies tool you like. Implementation. Let's discuss about how you can achieve that goal. You need to spin a vanilla EC2 instance up. You need to configure and deploy your application, export AMI, and tear everything down to reduce costs. That is what you need to do. So in 4 steps, you are good to go. This presentation is based off a projects I worked on recently, and I streamlined the playbook that I used, and it's available on GitHub. So feel free to give it a go to start cracking on that. So to spin a vanilla EC2 instance up, you might leverage this YAML playbook, which allows you, so this is a beef or tofu if you're a vegetarian, and essentially what you need to do is just to add a new instance in EC2. Then you just need to wait for that EC2 instance to be properly spun up. Obviously it takes some time, maybe just seconds, but you just need to wait before proceeding further. Then you need to configure and deploy stuff there. Let's say for the time being we just install Apache just for the sake of this talk. But you can expand on that. You can really add whatever complexity, level of complexity you want to this. As soon as your configuration management system has converged, you have a fully working server running in the cloud. So you are ready to take an image. You can create an AMI and tear everything down to reduce costs, which is performed by this part. So essentially, you just need to specify the region where you want to store the AMI in, and just name it. And by naming it, I mean you can use a naming schema of your that you agreed in with your team, and add AWS tags to that. And terminate the instance that you previously launched. So the CI/CD workflow works like this. So you have an AMI image based off the EC2 instance that you provisioned. You tagged that AMI, and you can reuse that in dev, run tests. If everything is fine, you can promote it to UAT, again, additional tests, promote to pre-production environment, test again before going live, and when you're happy, you can promote it to live eventually. So just to recap what you are supposed to do to achieve this goal. You just write your implementation, which allows you to provision that server to run your application. You can store those runbook on GitHub repository, then let Jenkins kicks in. Feed Ansible with some sort of YAML playbook. Pick a Linux distribution of your choice. Create the AMI, tag it, version it, store it in a bucket, and spin EC2 instances based off that AMI. And you're ready to go to promote that image throughout all environments that you are supposed to manage. Lesson learned. I've been working with, I think, pretty much all configuration management systems. Ansible is the only way to go with if you want to keep things simple. Horses for courses. There is no one tool which allows you to do all things in the right way. So just use what you are familiar with and consolidate what you are doing. Use the right configuration management system and CI/CD pipelines the right way, and version, and test all the things. If it doesn't work, nuke it and reprovision it from scratch. That's the easiest and safer way to do. Thank you very much, guys. That was my slide deck, and you can reach out to me on Twitter or by email, or feel free to come talk to me today, this time, or any break time.
Yeah, questions? Okay.
Hello, thank you for your great presentation, and I have a couple of questions. First one is what is the advantages of your way and doing that with Packer?
Doing, sorry?
Packer.
Ah, yeah. Yeah. Exactly. Sure. It's the other tool by Ashcorp. As I said, so I used Packer previously for another project. As I said, I like to keep things simple. So if you want to use Packer, eventually you need to write some sort of runbook to provision your machine.
Same thing, you doing YAML-based bit that then run Ansible with Packer.
Yeah, that's correct. So if you use Packer, you need to use two tools. Packer plus a configuration management system to provision stuff. With Ansible, you can achieve the same goal with just one.
Okay.
That was my point. I use Packer, and it's awesome. I really like it, but just a tool that you can ditch.
Okay, got it. Thank you. The next question is a tougher. What if we exclude these instances and, for instance, use callback in Jenkins to do the stuff when we actually spinning up a new instance with Ansible?
Okay, so I'm not sure if I got it correctly. You are saying that you would spin an EC2 instance up and then use Jenkins to provision those EC2 instances?
Yeah, exactly. If we include, for instance, into our metadata instance, our launch group instance, a callback to our Jenkins to actually configure and, I don't know, adopt our instance for ready-to-use state and test it and doing stuff like that.
Yeah,
What
sure.
do you think about that?
I think that could work. Why not?
Is it a better way to do this stuff than packaging and images?
Okay, so you would leverage those that approach to provision systems at runtime. So essentially, you're just using Jenkins as a configuration management system. So you would use Jenkins instead of Chef server or Puppet server.
Not really. We can reuse in Chef and Puppet to actually configure our instance, but we do not messing with all these pre-built IMIs.
Yeah, I mean, it's a different approach. I like to have everything in place when it comes to managing production environment. I don't want to build and provision systems at runtime.
Okay.
That is my experience. I just wanted to share my experience, which is just keep things simple. When you need an EC2 instance up and running, just leverage an AMI which is already available, and there are no questions. It works.
Okay, got it. Thank you.
Thank you for your presentation. Can you switch slide with the workflow of deployment with GitHub?
This one?
Back, please. No. Oh,
Yeah.
thank you. Yes. This workflow can be implemented with Docker. Absolutely. Why not Docker? This no vendor lock with Amazon, no any dependencies, no Ansible. You can run anything on build time. You have Onion file system. You reduce usage for space. Why not Docker?
That's a good question. So, do you want the short answer or the long one? So, the short answer is if you use Docker that way, you are just using Docker to replace virtual machines.
No. Docker is no replace virtual machines. Docker can run on all virtual machines, on physical servers, on bare metal.
Is it web scale?
So,
I'm sorry.
No,
your images works on your application is absolutely stateless. Yes.
So I'm not talking about containers on purpose, or honestly. Containers are awesome. I like that. What I'm saying is that if you work in already well-established team, you might already have cookbooks, manifests, or playbooks already there, and they are already developed and they work smoothly. I'm not talking about somebody who starts from scratch.
Okay.
So if you already have something, you might want to consolidate your infrastructure. And to consolidate your infrastructure, the only way to amend the minimal number of changes is to adopt AMIs. If you want to use something completely different and to adopt a new mindset and way of doing things, containers are the way to go.
Okay. Really, it's right. But when your application inside the EMI, has a state.
Yeah.
You can change it on the fly by image reinstalling, by instance relaunching. This state will be less. Okay. I guess state on S3 on or another place. Yes. On the
I think I'm lost. We might take this offline. Maybe it's easier.
State for application is, I guess, in your case, state on this application is split on the image. Yes, is right.
The state of the application. What do you mean by that?
Like logs.
External storage.
External storage.
Yeah.
Okay.
I think I'm lost, but we can take that offline.
Okay. Yeah.
Well, thanks for the talk. Actually, I think that this is a really nice way to get the Docker thing to the like legacy infrastructure, and it's nice way to do it. And my question is, what if I start in something new? I'm looking into ways that are there to implement my infrastructure.
Yeah.
And are there some advantages of this way comparing to Docker or more modern ways? When I should choose this way from the start?
So I would suggest you to adopt this approach when it comes to reusing what you already have available in-house. So if you already have playbooks, manifests, and cookbooks already available, then that's the easiest way to get those automation. But if you are running from scratch, if you are starting from scratch, nothing really prevents you from using Docker. I would honestly go with that. Yeah, it really depends on what is your goal. Yeah, exactly.
Yeah. Thanks.
What do you think?
What do you think about SaltStack? Have you tried it?
No, I've heard many awesome things about SaltStack, but I never gave it a try. It's the only one missing, honestly.
Okay.
Apart from Sims Engine, but nobody likes it.
Yeah. Okay, and one last question from me. How big is your production that's handled by all this thing?
Sorry.
How many instances do you have in your production systems that are handled by
Right
this
now.
process?
You mean the chef and packet infrastructure or the real system?
Or real system that is managed by this.
How many nodes?
Okay, we are talking about tens of machines. Yeah.
Okay, thanks. So, thank you. We have additional break. And
Thank you.
thank you very much.
Thank you.